All right, so today we're going to introduce or reintroduce, in some cases, polynomials and some ideas that surround them. Okay, we're going to look at just what makes something a polynomial. Okay, and then how do I name them and like different characteristics of them, and then we're going to talk about doing some math with them as far as like some arithmetic, I should say, adding and subtracting today. Okay, so let's kick things off here. So a lot of vocab coming at you. Okay, so just heads up on that. I'm going to try and use it as much as we can here, because the more we use it, the more fluent we'll become, right? Just like your foreign languages, right? The more you speak the language that you're trying to learn, the better you'll be able to learn it. Okay. So let's go. Page 805 is where we are. Page 805. For those of you who are still looking at page 805. So we're going to start just kind of introducing the idea of expressions with polynomials and stuff like that. Before we talk about polynomials, though, we're going to look at monomials. Okay? So mono is a prefix meaning not the same. One. Okay? If you guys like ever play around in some settings for like audio and stuff like that, sometimes, and maybe they don't have this option anymore, but there used to be an option where you could have like mono or stereo, right? And the idea is when you, what was that? You've seen that. So right. So the idea is like when you have stereo, normally like I think of it in context of video games, but normally the stereo means they use the two different speakers and different sounds come out of each different speaker to kind of make you more immersed in, the scenario or whatever kind of thing. Whereas mono, it's all the same sound coming out of the left speaker and the right speaker, okay, kind of thing. So you're using one, essentially one speaker. What's that? Don't get mono, right. Mononucleosis is what that's short for, and I guess that has to do with one nucleosis. I don't know, one something. So a monomial is an expression consisting of, and now here's where we have to, understand. So a monomial is an expression, so no equal signs, just an expression consisting of a number, variable, or product of numbers and variables that have whole number exponents. Okay, whole number exponents. A monomial cannot have more than one term. Also important, a monomial cannot have more than one term. And it cannot have a variable in its denominator. Okay, so monomial, that's the idea of the mono part. It's one term. And it can have numbers, variables, or a product of numbers and variables as long as there are only whole number exponents. And a monomial cannot have more than one term, which makes sense. It wouldn't be a monomial anymore. It would be like a binomial or a trinomial if it had more than one term. And it cannot have a variable in its denominator. So you can look here at some examples. Okay? 4, it's a number, so monomial. X, it's a variable, monomial. Negative 4xy is a monomial. But Mr. Witt, there's 3 things there. Yes, but those 3 things are all together one product. And so that's why it's still a monomial. Same thing here, monomial, 0.25x to the third. Okay, that's good to go. This one, you might be like, oh, Mr. Witt, there's a denominator. Okay, yes, but dividing by 4 is the same thing as multiplying by 1/4 xy. So these are equivalent, and so xy over 4, that's still a monomial. Okay. Now let's look at some things that are not monomials. Why is 4 plus x not a monomial?
Because there's 2 variables.
Not two variables.
Or
2 terms. 1, 2. They're separated by addition. That's what creates new terms. So there's 2 terms here. Okay.
What is the number? What is the variable?
That doesn't matter so much, but it's more that there's 2 terms, and you can't combine them together as a single one. And that might that helps what you're saying there, because one's a number, one's a variable. You can't put them together, so they stay 2 terms. Same thing here, right? 2 terms, so not a monomial. What's wrong with this one? There's only 1 term here. What's wrong with this one? Why is it not a monomial? I'll zoom in maybe here. What about it makes it not a monomial? Tyler? The exponent? Is that what you're going to say too, right? Yeah. Negative exponent, okay? Because the only kind of exponents we can have are whole number. Negatives aren't allowed, so that's the problem right there. Okay? What about the next one? Well, I guess this one's kind of obvious too. What's the problem with this one? negative exponents, right? Can't have negative exponents again. All right. And then what about the last one there? Shepard, what's the problem with this? Why is it not a monomial? The what? So an x to the third is not a problem, but Shepard, where is the x to the third? In the what? Yeah, the denominator, the bottom part of the fraction. So no variables in denominators. Okay, so that's not allowed. Not a polynomial. Okay, and the reason why it's important for us to classify what is and what is not a polynomial is because polynomials, as a group of things, they kind of all have similar characteristics, and so it's important for us to see, oh, if this thing's part of polynomials, then we can expect these kind of characteristics. If we see something that's not a polynomial, well, then we can't make those generalizations and stuff. So yes, Sean. I guess so. Yes. If you want to go, well, I mean, if you can wait, I would say wait. But if you can't, I mean, I get it. You got to go. But guys, you should really be taking care of this when you're, in the lunchroom or something like that. You were just there for a whole half hour, okay, or on the way back from the lunchroom because, again, every time you leave, you miss instruction. So, anyway, use the following process to determine if 5ab squared is monomial. Well, do we really need to do that? I don't know. I mean, is 5ab squared a monomial? Yes or no? Let's go to Erica. What do you say? Is that a monomial? Okay, why do you say no?
I don't know.
You're just guessing?
Yeah.
Okay, so again, go back to your definition up here, Erica.
Actually, yes.
It is, okay, yeah, it's a number or a variable or it's a product of numbers and it's that third one, product of numbers and variables, right? Mm-hmm. It does not, so does it have more than one term? Nope, just one whole term there. There's no addition, subtraction, and it's there's no variables in the denominator, right? There's no denominator, so it is a monomial, okay, monomial, okay? Let's skip down here to letter G. Okay, is 5 over k squared a monomial? Let's go to Daniel. What do you say, Daniel? Is 5 over k squared a monomial? No, Daniel says with a question mark at the end. Hannah, what do you say? 5 over k squared, is it a monomial?
No, because one has a negative exponent and the k is in the denominator.
Okay, yeah, so that's interesting you said that. So yeah, 5 over k squared, we could rewrite that as 5k to the negative 2. But more importantly, yes, there's a k in the denominator there. K in the denominator, variable in the denominator, so no. Variable is in the denominator. Okay, oops, I'm off the screen, there we go. All right. Questions on that so far? Making sense? Okay, let's continue on here. We have a whole table now to look at. All right, we have a whole table to look at there. So let's do it here. All right, we've got 5ab squared. Whoops, I got to zoom out just a skosh. Let's see here if I can do this. Can I make everything that I want to happen? Okay, yes. Oh, a little bit more. Okay, so we've got our terms. Or expressions here. We're asking, is it a monomial? And then we're asked to explain. So let's go through it here. Let's go to Simon. X squared. Is it a monomial, Simon? Yes. Yes. Okay. It's, well, I guess how do I explain my reasoning here? I could say x squared is a variable with a whole number exponent. Okay? Square root of y is not a monomial. Can anyone explain why that is the case? Square root of y, why it's not a monomial? This is a bit tricky. Yeah, Tyler? Square root, it doesn't become negative. Think about, do you guys know what the exponent is for a square root? Yeah, I don't know if you guys have talked about this before, but the answer is no, and it's because square root of y, and we'll learn this later, is the same thing as y to the 1/2 power. Ugh, stupid handwriting. Okay, square root of y is the same thing as y to the 1/2, and remember we need whole number exponents. So 1/2 is not a whole number. Okay, a whole number exponent for our variables there. Okay. Ben,
Yes.
is 2 squared a monomial?
No.
No. Why not?
Because there's 2 numbers.
Okay.
No, that's not right. Because it's an exponent.
Okay, it does have an exponent, but we had an exponent here with x, and it was a yes.
Oh. Then I don't know.
What is 2 squared equal to, Ben?
2 squared?
Mm-hmm.
4?
Yeah. Is 4 a monomial?
Oh, yeah.
Yes. So 2 squared, because it simplifies to 4, we can say it's a monomial there. Okay, that maybe is the easiest way to say it there. Okay, 2 squared equals 4 is a number. Okay, let's go to Carson. Carson, we're already told here 5 over k squared is not, but why not, Carson? What's the problem with this thing?
Does it have an exponent in the denominator?
Not an exponent, a variable in the denominator. Okay, you guys go ahead then and try the next 3. 5x plus 7, x squared plus 4ab, k squared over 4. Okay, say yes or no for if it's a monomial, and then if you say yes, explain why you think it is, but more importantly, if you see it's not, explain why not. So go ahead and take like a minute or 2 here and figure that out. Okay. Think about it. Think about it, man. Yes or no for those last 3. Yes or no. Why or why not? Yes. There's going to be some from here, yeah. Right now, something like here is. And then I think this one. Yes. And we're going to do a few more things later in the next section. But I want to.
Say 17 too.
What's that?
You said 17 too.
Yes. I think I did. Let me check. Yeah, so 4 through 12. 17. And then some parts. Okay, let's see what we got here. Looks like most people are done. Okay, so Caden, what do you say? 5x plus 7, Caden, yay or nay? Is it a monomial? No. Why not? 2 terms, right? Separated by addition there. Okay. Let's go to Ella. Ella, what about x squared plus 4ab? Monomial? No, 2 terms as well. By the way, right, if we call something with 1 term, if we call a polynomial with 1 term, we can call that a monomial. You can also still call it a polynomial, but we call it a monomial. If it's got 2 terms, what do you think we're going to call it? What's a prefix for 2? So, yep. Binomial. 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 Bike, like a bike, right? Two wheels, bicycle. Okay. Let's do the next one here. K squared over 4 will go to Alex. Yeah, sure. Alex, what do you say, Alex?
Well, I was originally thinking no, but then I looked at it more and I changed my answer to yes because you can divide it.
Mm-hmm. Mm-hmm. So the answer is yes. We have a fraction, but there's no variables in the fraction. It's just the 4. Okay. So since it's just a 4, we can say that it is a monomial there. Okay. If we had a variable down there, it would be no.
So how would you write, I mean, because I wrote down all the reasons why it is 1, but how do you say it in simpler terms?
In simpler terms,
How would you say it? What would you put in your
yeah, I mean, I would say something like this. K squared over 4 is equal to 1/4 k squared. And so it's 1 term that is a product of numbers and variables. Something like that. Yeah, it's kind of harder to do the description for when it is a monomial because you have to kind of go through all the pieces. It's a product of number and variables.
What I did.
Yeah, it's no whole number exponent. No variable in the denominator, stuff like that. Now, here's something I do want to point out here. Okay, 16 to the 1/3, this is the next part here in the discussion. And this is an important distinction I want to make here. 16 to the 1/3 power, that is a monomial. And you might be like, but Mr. Widmeyer, that exponent's not a whole number. It's 1/3, that's a fraction, not a whole number. Okay, 16 to the 1/3, though, it is a monomial. But x to the 1/3 is not a monomial. Okay, why is that? Anyone have an idea there about what the difference is between, what's the difference between 16 to the 1/3 being a monomial and then x to the 1/3 not being a monomial? What do you think, Ella?
Maybe the 16 to the 1/3 power simplifies to a whole number.
Okay, so the key there is that, yes, the 16 to the 1/3 simplifies. So we can write it out as a decimal here. Okay, so it's a single value. So you can actually like simplify it and evaluate it. X to the 1/3, it doesn't simplify anymore, and the exponent is going to have to stay a fraction. You can see here, 16 to the 1/3, we can actually like do that and eliminate, we can do 16 to the 1/3, we can eliminate that exponent that causes the problems, right? We don't want not whole number exponents. But with the x to the 1/3, we can't simplify that because we don't know what x is. Okay, so 16 to the 1/3 simplifies. So the 1/3 goes away. X to the 1/3 can't simplify. So it isn't a monomial. Okay, we keep that, we have to keep that 1/3 exponent there. Okay? Questions on any of that? Okay. X to the 0. What about that one? Is it a monomial?
Yes.
Is it a single term?
Yes.
Or does it have a negative exponent? No. Okay. And so it's no negative exponents, right? It's a single term. What is it when you raise something to the 0? Do you guys know what happens when you raise something to the 0? It's not 0.
Oh, that was going to be my guess.
Yeah, it's so let me just do with the number. A to the 0, it's 1. Anything to the 0 power is 1 except 0. So we'll say yes as long as x does not equal 0. Because if x is 0, 0 to the 0 is actually, mathematically, that's got some weird stuff going on there. Okay. So hopefully you have a better idea there about what a monomial is and is not. Okay, but now we're going to jump to some more vocabulary. A polynomial can be a monomial or the sum of monomials. Okay, so a polynomial is a combination of monomials, but it can also include monomials. So a polynomial is like a bigger, broader category, okay, of terms. All right, so think of it like, a polygon, right? You guys know what polygons are? They're your shapes, right? And then within the category of shapes, you might have, like a polygon, you might have like a three-sided shape. And we call a three-sided shape a triangle, right? So the triangle is like the monomial or the binomial or the trinomial. It's a specific kind of polygon, okay? Just like the polynomial, right? A specific kind of polynomial is a monomial. It has a single term, okay? But a polynomial can be a sum of monomials too, and you can then rename it based off of how many monomials you've got. If your monomial has one term, a monomial has one term, a binomial has two, and a trinomial has three. Okay, so if you look right here at this example, 8xy squared minus 5x cubed y cubed z, how many monomials are in this expression? Whoop, wrong direction. How many monomials are in this expression here? How many terms are there? Let me say that. How many terms are there? 2 terms. 8xy squared and 5x cubed y cubed z. Okay? 2 terms. So that means it's a binomial. Okay? Binomial. No, if you say, for example, if you read the sentence,
Oh,
for example is a binomial.
gotcha.
Yeah. Okay. Polynomials can also, so they can be named based on how many terms they have, but they can also be classified by their degree. The degree of a polynomial is the greatest value, okay, highest or greatest value among the sums of the exponents on the variables in each term. Okay, in each term. So let's go back to that example we were talking about earlier. It's killing me here. Stuff to my desk. Okay. So the binomial 8x squared minus 5x cubed y cubed z has two terms. Okay? The variables in this first term are x and y, and the exponent on the x is what? When we don't have an exponent written, okay, when we don't have an exponent written, what exponent do we assume here?
1.
A 1. So I'm going to put a 1 there. Okay, so to find the degree, so to find here, to kind of evaluate our degree, we'll add the 1 and the 2, so that's 3. Okay? So this has a power of kind of like a total power of 3 here. If we go to this next term, we have a 3, and the z has a what exponent? 1. So 3 plus 1 is 7. Okay? So which one's bigger? 3 or 7? 7's bigger, right? So we say the degree then of the overall expression here is 7. You take the highest powered or highest sum of powers term. So this has the highest sum, 7, and so the overall degree of this thing is 7. Okay, so degree equals 7 there. Okay, degree equals 7. Alrighty, questions on any of that? All right, so let's take a look here at letter A then. Try and tear this page out without making a mess. Okay, there we go.
I have questions.
Question.
So, this is all very interesting, the degrees.
Mm-hmm.
And so if I were a mathematician, like say Mr. Wiedemeyer,
Mm-hmm.
and I was looking at something and I was sort of saying, oh, it has a degree of 7.
Mm-hmm.
Yeah.
It will become more meaningful as we go. Right now it's
It will
important.
become clear?
Well,
Oh, thank you. Okay, I shall be patient and wait.
mm-hmm. Okay. Yeah. So let's go to our next page here on page 807 then. Classify each polynomial by its degree and the number of terms. Okay, so let's just zoom in there on letter A. Again, this is page 807. Okay. Okay. So, Matt. First of all, Matt, what kind of polynomial is this? Let's decide that first. Describe it that way first. Yep, you, Matt. Sorry, Matt S. How many terms are there? Two. So again, look for separations between addition and subtraction. So we've got one term here, one term there, two terms. So two terms means we would call it a, what kind of polynomial is it? Monomial, binomial, trinomial? Binomial. And by the way, folks, if there happens to be more than 3 terms, we don't really call it like a quadrinomial or a tetranomial or anything like that. We just say it's a polynomial after that. Okay? We really only go up to 3 terms, and then we just start calling everything a polynomial after that. Okay? Very good. All right, thank you, Matt. Now let's go to Caden. Caden, for this first term here, what's the degree of the first term? Sorry, we're on page 807, letter A. Sean, what's the degree of this first term here?
What's the what?
What is the degree of this first term here?
7?
7? Nope.
No.
I'm going to try someone else. Make sure you pay attention here. Daniel, what's the degree of this first term here?
5x.
For the first term.
7x.
Nope. Come on, man. Here we go. Kendall, what's the degree of this first term here? 2. How'd you get that, Kendall? Where'd you get that from? The exponent. That's all it is there, guys. It's the exponent. Sean, Daniel, you might want to keep your head up. If you're not getting this stuff, the answer is 2. Okay? In fact, Daniel, whatever you're looking at, go ahead and put that away. Okay, maybe you should put it away because there's no reason for you to be calculating right now. Okay? Thank you. All right, the degree here is 2. What about this second term? Let's go to Tyler C. Tyler C, what's the degree of this term right here? Not 3. Let's go to Daniel again. Daniel, what's the degree of this term?
6.
It is 6. Daniel, where'd you get the 6 from?
3 plus 3.
Yeah, we got to add the exponents there, Tyler. Okay, be careful. Add the exponents. So degree here is 2. Degree here is 6. So the overall degree, what are we going to say? Anybody? 6. You just take the highest power. You don't add them up or anything like that. You just take the highest power of the individuals here. So the degree is 6. Okay? Yes, question, Tyler. Sure, Tyler. If you think that's the best use of your time right now, you go ahead. All right, guys. Let's keep going here. Letter B. Letter B. All right, let's go to Dylan. Dylan, letter B. How many terms do we have here in letter B? 3. So this is classified as a what kind of polynomial? Trinomial. Okay, very good. And let's go to, let's see here, Kendall. Kendall, what's the degree of this right here? Yeah, so that's a little bit tricky, is there? Are there any variables here, Kendall? No. So there are no variables. The degree of this term is actually 0. Because we don't count variables with, we don't count exponents with numbers. We only count exponents with variables. So in this case, the degree is 0. Okay? What's the degree of this term, though, Kendall? 3. And what's the degree of this term? 1. So we have a 0, we have a 3, we have a 1. So the highest degree, or what is the degree of this polynomial? Let's go to Matt T. What's the degree of this polynomial, Matt T? Let me zoom in some. Again, Kendall said the degree of this was 0. The degree of this is 3. The degree of this is 1. So the degree of this polynomial, this trinomial, is? Nope. Nope. Sean, help us out. What's the degree of this polynomial? Nope. Let's go to Hannah. It's 3. Folks, look, I don't know what to tell you here, okay? I don't know. I want you guys to learn this stuff. I do, okay? And it's not that easy, okay? But I need you to, tune in here or something because, we need to know how to do this. Yeah.
So,
Liv.
sorry, I have a question.
That's great. I'll be happy to answer questions.
How's 3 with the exponent 2 0?
Because so for degrees, when we're calculating the degree, we only look for exponents of variables.
So it has to have an n.
Correct.
Okay.
Yep, and so this n by itself with no exponent written, we assume there's a 1 there, right? You can put a 1 in if you want to. Okay, but this has no exponent. It's really just 9, right? We can simplify that to just 9, so it's got no degree. The degree is 0. That's degree 3, and that's degree 1. The overall highest power is 3. Okay? So, let's keep working with this here. So let's look at number 5. Okay, scoot down here to number 5. Okay. How many terms is it? Let's go to Hannah T again. Hannah, how many terms is there? So we call that what kind of polynomial? Trinomial. Okay. And then let's go to number 6. Oh, wait, I'm not done yet. Sorry. Let's talk about the degrees here. So let's see here. Alex, what is the degree for the first term here?
4.
4. Good. What about the second term?
2.
But what is the x's exponent, though, really?
I guess 3.
Yeah, it'd be 3 total because that's a 1 there. And then what about for this one right here, Alex?
Just 2.
Very good, Alex. You're getting it.
Simply
Awesome.
stated.
What's the degree then, Alex,
Of all of them?
of the whole thing?
Well, you do. You stop shaking it.
I'll try.
Uh,
You said this one was 4. You said this one was 3. You said this one was 2.
You take the one with the highest. So it's
Highest one.
4.
4 is it. That's right. Erica.
Yeah, I do that.
Question?
I was
Can I ask
testing
you
you
a
guys.
question?
I was
Okay.
testing all
And then
of
you're going to
you
go?
guys.
So, more importantly, guys, I want you all to pass, okay? That's the important part here. I'm not trying to, like, how do you guys compete about who did or did not pass. I want you all to, okay? There shouldn't be a competition. It should be who passed by the most. That's what I want the competition to be. So, let's continue on here, okay? How many terms does this have? Let's go to Reagan. Reagan, how many terms does this have? 2. Very good. So, Reagan, we call this a monomial, binomial, or trinomial? Binomial.
Good job.
Okay? The degree. So, Reagan, I'm going to have you work through this a little bit too. The first one, Reagan, remember that A, what's the exponent for the A that I could write here? A 1. So, what's the degree of this term? 3. 1 plus the 2. 3. Okay? What's the degree of this term? Again, I could put a 1 with the B. What's the degree of this term? 3 as well. So, what's the degree overall of this thing? If that's 3 and that's 3, what's the degree? What's the highest powered? Don't combine them. Just 3. Yeah, we're not. I know it's like weird. We combine them sometimes. We don't. So again, big picture here, folks. Combine for the term. But then when you're comparing them, you don't combine them. Okay. For the whole thing, we'll just say whichever one has the highest power. And that's the degree. Okay. So here we have a 1 plus 2. That's a 3. That one's a 3. So the overall degree is 3. It's the biggest one from those terms. When Erica comes back, yes. Okay. Folks, again, try to make sure you're using that bathroom at better times. I feel like we get like, and I know, math is boring, right? You've been sitting here now for almost an hour. I get it, but
No, this is really
instruction.
easy.
I hope so. I hope so.
We should work on this for the rest of the term, maybe.
Huh. Well, for this unit, we're going to be doing stuff
What
like
else do
this.
we have after this unit?
We have things we got to learn now, so I'll answer that question later, okay? So, next thing, writing polynomials in standard form, okay? So, when you are asked, because there's just like how we had forms for lines, like slope intercept, point slope, okay, we have something called standard form for a polynomial, okay? The standard form of polynomial containing only one variable is written with the terms in order of decreasing degree. The first term will have the greatest degree, the next term will have the next greatest degree, and so on until the final term, which will have the lowest degree. Okay? So, when written in this form, the coefficient of the first term is called the, makes sense, leading coefficient. So if you look here, right, at our polynomial, is this written in standard form? Do our degrees decrease as we go through our polynomial here? They do. We start with a degree of, what's the degree of this? 4, and then, yeah, 4, 2, 1, 0, okay? So that's descending order, okay? What is the degree of this polynomial overall, though? Let's go to Matt T again. What's the degree of this polynomial overall? This is page 807, bottom left corner. What's that? 4 is right. It's a 4th degree polynomial. You'll notice there's 4 terms here. We're not gonna name it anything other than just a polynomial, right? Not a trinomial or a binomial because there's 4 terms here. Okay. What is the lead coefficient? Let's go to Dylan. What's the lead coefficient then, Dylan? 5. The number out front when you're in standard form. Okay. So you have to be in descending order here, standard form, and then the lead coefficient's the number out front there, 5. Okay. The math, the name tells you, kind of the order and stuff like that. Okay. Let's skip to page 808 and let's just skip to some of the problems here, like 7, 8, 9, and 10. Let's look at number 7. Okay, so page 808, number 7. Okay. 808, number 7. Okay. Biggest power to then smaller powers, yeah. Mm-hmm. So let's take a look here. So Ben, what is the highest power term? What's the highest degree term here?
5.
X to the 5th, right? Okay, so that one's going to go first, and it's a positive x to the 5th.
Yes.
Okay, so we took care of that one. Then what's the next biggest one there, Ben?
3.
Okay, 4x to the 3rd. And again, it's a positive 4x to the 3rd, so we'll make it positive 4x to the 3rd. Okay, that one's taken care of. All right, Ben, what's next?
2.
Yeah, the minus 3x squared. So it's a minus in front of the 3 there, folks. So you're going to write minus 3x squared when you rearrange it. Okay, took care of that. And then what's left?
10.
The 10. Okay, and that's, what's the degree of just a number? Degree is what? 0. Okay, my little b over there. That's right, 0. All right. So, what is the leading coefficient here, Reagan? Now that it's in order from greatest power to least power, what is the leading coefficient of this? What's the lead coefficient? What's the coefficient of x to the 5th? What number could we put there?
1.
A 1. So the lead coefficient here is 1. It's kind of hidden. It's a 1. Okay, the lead coefficient. Good job, Reagan. Okay. What is the overall degree of this polynomial? Let's go to someone who's here. Let's go to Liv. 5. Very good. Good job, Liv. Degree is 5. It didn't ask for that in the directions. I just wanted to make sure we could do it okay. Degree is 5. Okay, go ahead and try 8 and 9, please. Go ahead and try 8 and 9 on that same page, okay? Write it in standard form. Give the lead coefficient, please. Okay, go ahead and try 8 and 9, please. 8 and 9. 8. Look at your exponent there, a little closer. Okay, try 8 and 9. There's what I'm talking about. Okay. 8 and 9. Order from greatest to least, you just take the leading term, and that's the lead, it's the coefficient of the leading term.
So x would be 1.
So well, it'd be, since there's no variable, or lead coefficient, put 1 there, but like here would be -3, right? And here would be -5. Okay. So we're actually working on.
Sorry, I'm back. I got to see my first thing show getting my second page for Christmas.
Gotcha. Well, we're on 8 and 9 if you want to give it a try. Okay, we're rewriting in descending order. Standard form. So then the lead coefficient would just be 10. Actually, but don't forget this because that's like terms of mine. Bless you. Bless you. I would simplify it first, yes. So yeah, okay. So yeah, let's take a look here, just because of time. All right, back up front here. Let's talk to Simon. Simon, number 8 is what's our highest powered term here? Yeah, the 8. So we're going to write -3y to the 8, and then what's the next highest powered term?
5.
Yeah, the 18y to the 5th. And then after that, well, it's only one thing left, right? So it's got to be the 10y. Okay. So Simon, and this is not part of the directions, but there's 3 terms, Simon. So what other name can we give this polynomial? Besides polynomial, what else can we call it?
Binomial.
So binomial is for trinomial. There you go. So it's a trinomial. Okay. What's the degree of this trinomial, Simon? 8. Very good. All right, one more question for you. You're doing a great job. You're on a roll. All right. What is the lead coefficient of this thing? Just -3 is all you need. Just the number in front, -3. So lead coefficient is -3 there. Yeah. And then we wrote it in standard form. That's all the directions asked for, but I just asked a bunch of extra stuff. But you did a good job there, Simon. Good job. Okay. All right. Number 9. Now this one's a little bit funkier, so let's go to Tyler C. Tyler, what can we do here with this?
Okay. So you got 10 and negative 15.
Okay, what can we do with those?
You can combine them.
Yeah, they're like terms here, so we probably should, right? And that makes negative 5x and then the plus 13. Is this in standard form now? What's the degree of the negative 5x?
There's 2 terms.
It's a 1. Yeah, there's only 2 terms actually because you can combine them. There's really only 2 terms, okay? And so the degree here, the degree overall is 1, okay? What's the lead coefficient, Tyler? Why don't you give us that one? Lead coefficient. X is the variable, but what's the coefficient of that term? Negative 5. Because these are both like terms, we should really combine them together first, and then we'll have a single term of negative 5x there. So really it's a binomial, negative 5x plus 13. Yeah, go ahead. Okay. Questions on any of that? Okay, I'm going to skip the explain on simplifying polynomials. We're going to get to that in just a second, but I want to move on to one more thing here. Page 810. Page 810. Well, I want to look there real quick. Okay, so turn to page 810. And I also have to talk about adding and subtracting polynomials too. Ooh, so we can do that, though. I think we should be able to get it done. Let me type them. I don't know why this takes so long. Why am I so bad at managing the time? Okay. So page 810. All right. I just want to talk briefly about 1 or 2 of these just so you guys kind of see what this is, because there's a lot of words going on here, but it's actually not that hard to do. Okay? So on page 810, we're going to explain for evaluating polynomials. So given a polynomial expression describing a real-world situation and a specific value for the variable or variables, evaluate the polynomial by substituting for the variables. Okay? So letter A, or the directions here just say evaluate the given polynomial to find the solution in each real-world scenario. Okay? So letter A, it's kind of done for us, but we'll just talk it through here real quick. A skyrocket is launched from a 6-foot-high platform with an initial speed of 200 feet per second. The polynomial negative 16t squared plus 200t plus 6, so this, gives the height in feet that the skyrocket will rise in t seconds. How high will the rocket rise if it has a 5-second fuse? That is...
Where did the 16 come from?
This is a poorly written question.
There's no. Where did the 16 come from?
So the 16, the negative 16, that's part of, this is actually like, it has to do with the acceleration due to gravity, or it's negative 16 because gravity is going to be acting against the rocket. They didn't talk about that part, right? Okay. What it should be here is how high will the rocket be 5 seconds after it is launched? That's not right. If it has a 5-second fuse, that's, unless it's talking about exploding, maybe, I guess. Maybe that's what you were talking about, Tyler, right? I don't know. How high is it after 5 seconds? Because a 5-second fuse, to me, would indicate you're lighting it, the fuse goes for 5 seconds, and then it shoots off. That's what I'm thinking, but that can't be right because, anyway. The point that what it's asking for here is how high is the rocket after 5 seconds? So, yeah. So we're going to plug 5 in for t here, essentially, and then just simplify it, okay? Please make sure you put parentheses around the 5 when you substitute it in, and then you can just do the arithmetic in your calculator. Okay, it's that simple. Let's jump to one that's not done for us here real quick. Lisa wants to measure the depth of an empty well. She drops a ball from a height of 3 feet into the well and measures how long it takes the ball to hit the bottom of the well. She uses a stopwatch, starting when she lets go of the ball and ending when she hears the ball hit the bottom of the well. Okay? The polynomial, negative 16t squared plus 0t plus 3, gives the height of the ball after t seconds, where 0 is the initial speed of the ball and 3 is the initial height the ball was dropped from. Her stopwatch measured a time of 2.2 seconds. How deep is the well? Okay? So if it took 2.2 seconds to hit the bottom, what should we do with that 2.2? Where should it go? Here's our expression that represents the height of the ball in the well, right? So what should we do with that 2.2 seconds? To find its height. What's that? I think I heard it. Here's our expression. Okay? Substitute, it said, I mean, after 2, so this is the expression for the height of the ball after t seconds. So what should we put in for t?
2.2.
Yeah, 2.2, guys. It's the stopwatch measured at time at 2.2. So after 2.2 seconds have elapsed or gone by, we'll just plug in 2.2 for t and then simplify. I'm just going to do it with my calculator to save us time. So negative 16, 2.2 squared plus 0 times 2.2 plus 3. Negative 74.44. So what does that number tell us? It is the what? Negative 74.44 what? Yeah, it gives the height of the ball, right? So this is feet. Now why is it negative feet? Because it's going down from us, right? It's decreasing in the height, right? So the well, we can say then, is 74.44 feet deep, right? We don't have to put the negative when we're saying how deep it is. Okay? And so it goes negative 74.44 feet below the ground. Like that. Okay? Questions on any of that? All good? Okay. So then turn the page real quick one more time here. Actually, yeah, we're going to do this real quick. Real quick. Run out of time. Okay, we're going to talk about adding and subtracting polynomials here. I don't like how they organize this, but we'll just do the best we can. So let's turn to page 819 real quick. I know, yeah, sorry. Actually, do I want to do 819? Maybe I'll just go to, yeah, never mind. We'll just jump to 823. Just go ahead and jump to 823. 823, 823.
Somebody wrote in my book already. Did you guys use these before?
No, I haven't. Someone did already, huh?
Huh.
Interesting. Did anyone else have their book written in? 823?
Well, hold you guys.
That's right.
I'm sorry, I got lost in that.
823, 823. Okay? And guys, I think you already know how to add polynomials together, right? When it comes to adding polynomials, let's look at number 3, for example, here. When it comes to adding polynomials, how do we determine if they go together or not? What do they got to be?
823 is ripped out.
It's ripped out.
Like turn.
What the what? Okay. Like terms. Right. So, Tyler, I will try and help you out as best I can in a second here. So, what are our like terms here in this problem? And that is like super. Oh, look at that. That's a little bit better. Okay. What are our like terms here? Oh, sorry, Tyler. So you go ahead. Okay. So x to the 2 is, oh, sorry, that's my musical time. So x squared is like with what?
Beautiful. When does it do that?
There's a thing at the bottom that I can squeeze. Does it? And because I pushed it up against the desk, it went off. Activated. So x squared is like with what? Huh? Santa's going to give you guys all coal for your Christmas presents. Come on now. Let's go. What is like with x squared? The other x squared, right? So we have a 1x squared minus a 1x squared. So what's 1 minus 1? 0. So they disappear. They're gone. Okay, they cancel out. 0x squared. Okay. What about the x to the fourth? What's like with the negative x to the fourth here? Positive x to the fourth. So they combine together. We have a negative 1 and positive 1. They cancel out. So we have plus 0x to the fourth. What's 0 plus 0? It's 0. Okay? 0. What kind of polynomial is this? Monomial, binomial, or trinomial? Monomial. One term. One term. One term. What's the degree of this monomial? 0. The degree of this is 0. Okay, the degree of this polynomial is 0 because there is no exponent there. Okay, so the degree is 0. Okay, so it's monomial degree 0. Okay, let's try another one over here, number 4. Okay, whoop, number 4. There we go. Okay, what are our like terms here? Let's go to Catherine. Catherine, or do we have any like terms here? Number 4 there.
1 minus 4 thing.
Okay, we have a negative 1x to the fourth and a positive 1x to the fourth. What's negative 1 plus positive 1, Catherine? Negative 1 plus positive 1. 0. So we have 0x to the fourth. So we took care of those two. Is there anything like with the y squared, Catherine? Does the y squared have another friend to go together with?
No.
Nope. So we have a plus y squared. And then does the x squared, the minus x squared, does that have anything to go with? Nope, so minus x squared, okay? So 0x to the fourth, it just goes away. Now we have y squared minus x squared, okay? Is this a monomial, binomial, trinomial, or just a polynomial? What is it, guys? Anybody? Binomial, 2 terms, okay? I don't know if we could talk about the degree here because we have different bases for our variables there. I guess you could say degree 2, but I don't know if I like that or not, okay? Really, it's just a binomial there. We'll just say that. Okay, so you get it. Adding is adding like terms. All right, we're going to turn the page one more time here. This is like race to the top here. Right, that was a thing back in the day. Miss Mulcahy remembers that. Race to the top. Race to the top. That was after No Child Left Behind, right? Was Race to the Top after No Child Left Behind? Yeah. All right, number 3. I won't say any more than that, though, because the walls have ears. So anyway, okay. Page 835, 835. We're going to talk about subtraction. We're almost done here. I've got to talk about subtraction, too. 835, number 3. 835, number 3. Number 3. We're looking at 835, number 3. Sorry, guys. Today is really jam-packed. I feel like it's always jam-packed. Thank you for trying to stick with me here. All right, so we are now subtracting. See, minus polynomials. When you have a minus in front of parentheses, what do we have to do with that subtraction sign? Starts with a D. Distribute it. Okay? When you have a minus in front of parentheses, the minus distributes to both terms in this case. So we have 2x squared minus 2x to the fourth, and it becomes minus with a negative minus a positive becomes minus positive x to the fourth, and then minus a negative becomes positive. We'll see x squared. I'm going to put the assignment on Google Classroom, okay? Yep. Okay? So you see the minus sign distributes to both terms there. The positive x to the fourth becomes negative x to the fourth. Then negative x squared becomes positive x squared, okay? So you have to distribute that minus sign, then combine like terms here, okay? So, Carson, what are our like terms here? 2x squared is like with the...
2x, 4.
Are those like?
No.
No, because that's got a 2, that's got a 4 there, right? What is this like with? There is something here. The x squared. And that's a, what's the coefficient here? 1. So what's 2x squared plus 1x squared? 3x squared. Okay, that's gone, that's gone. Are there any other like terms here? Carson?
Yeah.
What is it?
Negative 2x squared and negative x squared.
Okay, to the fourth. Yeah, negative 2x to the fourth minus x to the fourth. So negative 2 minus a 1 negative 3x to the fourth. Okay, and then I'm gonna reverse the order there because of the I want to put them in standard form. So it'll be now negative 3x to the fourth plus 3x squared, like that. Okay, and that'll be our final answer there. Okay, Carson, what is the degree of this polynomial?
4.
4. Good. It's the highest powered term there. 4. Okay, good. Carson, is this a monomial, binomial, trinomial, or are we just going to call it a polynomial? By 2 terms. That's right. Whew. All right, folks. We're going to pause right there. I'm going to give you guys your assignment for tonight. Okay? And it's going to come from each one of these 3 pages. But I'm not going to try and give you a whole bunch. Okay, what's that? Old book, I would say you can leave them back there on the shelf, and we'll maybe come back to them, but probably not. Okay, so here is your assignment. Page 812. Numbers 4 through 12 even. You might want to circle this and maybe dog ear it too. You know what I mean? Like fold the page so you can get to it quickly. So dog ear page 812, and you're going to circle 4 through 12 even. But I also want you to do 17 and 19 ABC. Okay. Then on page 824, I want you to do numbers 10 and 12. Okay, and then on page, again, dog ear that. I'd suggest you dog ear that too. Okay, you know what I mean? Fold the page down so you know where to go. I'm putting up on the page, on the board here. 835 as well. Numbers. 4 and 9. It's not. It's just spread out. It's really not that much. Because it's 3 different sections we're going from.
I'm taking a picture.
Okay, yeah, if you want to take a picture, that's fine too. Okay.
17's on page 813 and 19's on page 814, obviously, okay?
Yeah. You'll have to keep going there.
Yeah. Well,
Okay.
we have to take the book home.
Or you can tear those pages out. If you want to, folks, you can also just tear those pages out. But either take the book or tear the pages out. I recommend you just take the book. But that's me. Okay.
What do we do with our old book?
You can put it back on the shelf there if you want to.